In this video, we're going to look at section 9.1, using trigonometry with right triangles. There are three learning targets for this section. Learning target 9.1a is I can evaluate the 6 trigonometric functions of any angle. Learning target 9.1b is I can solve all unknowns of a right triangle. And learning target 9.1c is I can use angle of elevation or angle depression to estimate distances. We're going to start looking in this lesson at some right triangle trigonometry. So in order to do that, first we need to draw our right triangle. So if we have a right triangle that looks similar to this, we pick one of the acute angles to go from. So it's not the right angle, but one of the two other acute angles. So in this case, I just picked this bottom angle here, and we're calling it theta. Now theta is just a Greek symbol that we use to represent an angle in the triangle. It's just kind of like a variable. So if we're going from that angle, the angle straight across from it, the side straight across from it is called the opposite side. The side next to it, the one that's touching it, is the adjacent side, and then the side across from the right angle is always the hypotenuse. So you've got the side across from the right angle, which is your hypotenuse, the two legs, which come out from the right angle. The one touching it is your adjacent, the one across from it is your opposite. So now with our right triangle trigonometry, we have 6 different trig functions that you need to know. The first one being the sine. And now you may be familiar with the first 3 from previous classes, but the last 3 might be new to you. So the sine is always going to be that opposite side or opposite leg over the hypotenuse. The cosine is always going to be the adjacent leg over the hypotenuse. And then the tangent is going to be the opposite leg over the adjacent leg. So that takes care of the first 3, the main 3 trig functions that we look at. But then we can also look at what we call the reciprocal functions, and that would be your cosecant, your secant, and your cotangent. And they are just the reciprocals of the previous ones that we looked at. So cosecant is a reciprocal of sine. So since sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. Secant is the reciprocal of cosine, so it's going to become the hypotenuse over the adjacent. And the cotangent is the reciprocal of tangent, so it's going to become the adjacent over the opposite. So if you know the first 3 trig functions, then it becomes very easy for you to find the second 3, as long as you remember which ones are the reciprocal functions. One clue here is that your tangents always go together, but then for the other ones, just remember that the cos do not go together. So cosine has to go with secant, and sine has to go with cosecant. Another way to remember this is to remember the word SOHCAHTOA. So SOHCAHTOA. If you remember that word, then that helps you remember your first 3 trig functions. The first 3 letters represent the sine. So sine is opposite over hypotenuse. The second 3 represent the cosine. So cosine is adjacent over hypotenuse. And then the last 3 represent the tangent, where tangent is opposite over adjacent. And then again, you'd have to remember that the reciprocal functions, sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. You can just kind of reverse the order on those or flip over those fractions. So when looking at our trig functions of right triangles, I just mentioned the reciprocal identities, so I want to make sure that you got those down. So the reciprocal identity, the cosecant is equal to 1 over the sine, or remember that means the reciprocal, so it's equal to the reciprocal of the sine. Secant of theta is the same thing as 1 over the cosine of theta, or in other words, the reciprocal of the cosine function. And then cotangent of theta is 1 over the tangent of theta, or the reciprocal of the tangent function. Let's now look at an example of Learning Target 9.1a. So remember, Learning Target 9.1a wants us to evaluate the 6 trigonometric functions, and that's what this example is asking us to do. So they give us a triangle, and they want us to evaluate those 6 trigonometric functions of the angle theta. So in this case, theta then is that lower angle. They'll always ask you to do it of an acute angle. So the first thing I need to do, because they only give us 2 sides, we need to find that third side. So remember, to find the third side of a right triangle, you're going to use the Pythagorean theorem, where you take your leg squared plus your leg squared, and that has to equal the hypotenuse squared. So in this case, the hypotenuse, that's always the first thing you need to look for, is the side across from the right angle. We don't know that, so we're going to call it side C. So when I go ahead and set up my Pythagorean theorem, I end up with 7 squared plus 24 squared has to equal that C squared, or that unknown side, that hypotenuse that we don't know. So now I'm going to go ahead and simplify this. So 7 squared I know is 49, plus 24 squared is 576. And then add those two together, I get 625 equals C squared. Take the square root of both sides, so C is equal to 25. Now I've got the 3 sides of my triangle, so I can come up with my 6 trigonometric functions. And if it helps, write yourself a note at the top of the page for your SOHCAHTOA. So SOHCAHTOA. So it's a good idea to kind of have that handy, just to make sure that you're doing the correct trig functions. So we're going to start with the sine. So sine is the first part of that. Sine is opposite over hypotenuse. So from that theta, sometimes to me it's easier if I write on my triangle what side represents which side of my opposite, adjacent, or hypotenuse. Well, I know that the one that I just found, that C value, that's my hypotenuse, so I'm just going to put an H next to it. From the angle that I'm looking at, straight across from it, that's 7, or that's the opposite side, and then the side next to it or touching it, that's the adjacent. So now I've got my opposite, my adjacent, and my hypotenuse identified, which is going to make it a lot easier to find those 6 trig values. Because now the sine I know is opposite over hypotenuse. So if I look at that on my triangle, my opposite side is 7. My hypotenuse we just found to be 25. So the sine of theta is 7/25. But I still need to find the other 5. So the cosine is adjacent over hypotenuse, or 24 over 25. And then the tangent of theta is opposite over adjacent, so 7 over 24. And now I need to do the reciprocal functions. So let's look at those reciprocal functions. So the reciprocal of sine is the cosecant. So the cosecant of theta is a reciprocal, so flip it over, 25/7. The reciprocal of cosine is secant, so secant of theta, so flip over the cosine, is 25/24. And the reciprocal of tangent is cotangent, so the cotangent of theta is 24/7. And there are 6 trigonometric functions. So now let's look at another example of Learning Target 9.1a. And it says that if theta is an acute angle of a triangle and the cosine of theta is 3/8, what is the value of the cosecant? Well, in order to do the cosecant, remember cosecant is the reciprocal of sine, so the cosecant is equal to the hypotenuse over the opposite. Since we're looking at the reciprocal of sine, sine was opposite over hypotenuse, so cosecant is hypotenuse over opposite. So now what we're going to do is we're going to make ourselves a triangle using the information that is given. So I'm just going to draw myself a triangle. I'm going to put theta on here. So let's just say that theta is this lower angle. So this will be our theta down here. And then they tell us in the problem right here that the cosine is 3/8. Well, if we think back to, say, like our SOHCAHTOA, I know that cosine represents adjacent over hypotenuse. So adjacent over hypotenuse. So using those values within my triangle, so the adjacent side to theta, the side touching it, is 3. So I put a 3 on there. The hypotenuse is 8, so I put an 8 where the hypotenuse is. So now I've got two sides of a right triangle. I just need to find that third side so I can use it as my opposite and then use the 3 as my, or that'll be my, opposite there. So, and then my h being the hypotenuse, the 8. So I need to, since I have two values of a right triangle, I need to use the Pythagorean theorem to find the third. So let's just call this side maybe x. So x squared plus 3 squared has to equal 8 squared. Or x squared equals, or x squared plus 9 equals 64. So solve for x squared. So x squared equals, subtract that 9 over, so x squared equals 55. And then we take the square root, so x is equal to the square root of 55. And that unfortunately doesn't break down, so we leave it as the square root of 55. So now remember, that is what x represents. So this side of the triangle, which is the opposite side of the angle we've got. So when we go to do our cosecant, I now have all my values of the triangle, so I can plug things in. So the hypotenuse is 8 divided by the opposite side, which is the square root of 55. Now typically we make this as exact as possible, so we don't like radicals or square roots in the denominator. So I'm going to multiply both the top and the bottom by the square root of 55. So I end up with 8 square roots of 55 over 55. And there is my answer to the cosecant of theta.